everyone, I'm Preethi from the Department of Computer Science and Engineering. In our last discussion, we focused on software project management. That involved 4 P's. That is the people, product, process and project. So our today's discussion is on process and project metrics. So let us start off with what are process and project metrics. So before we start our discussion, what exactly is metrics? Metrics is nothing but sometimes it is considered as a system on a whole or a system as a whole, or it's a standard for measurement. So let us look into what exactly is process metrics. These process metrics are collected throughout the project as long as it exists, and it is giving us some kind of indicators that lead us in a long journey until the software process is completed properly. That is, until we have a proper improvement in the software process. So I repeat, process metrics is nothing but collecting these metrics throughout our project and on a longer span of time. And it involves a set of process indicators that help us to improve the software at every now and then. Moving to the next definition of project metrics, right? This project metrics is trying to enable the software manager to do few tasks. The first task is trying to assess the status of the existing project or the present project or the ongoing project. So the software project manager has some features to be followed in project metrics. The first one is he has to assess the status on a daily basis, and he also has to focus on the risks. Next, he also has to uncover the problem areas before they move to the complex errors. That is, before they move into some critical conditions or critical positions, he has to look into removing that errors or trying to uncover the problem areas. Next, he also has to focus on the workflow or try to adjust the workflows, right? This is another task that a software project manager has to focus in the project metrics. Moving to the 5th point, that is trying to evaluate the project team. Why do we have to evaluate the project team? So that you will be having a control on the software that is providing us a quality product. So moving to process metrics and the project metrics. As we have said, it is trying to collect the overall project over a span of time, and it provides a set of process indicators, and the project metrics involves the software project manager who's trying to focus on the status, trying to control the risk, trying to remove the errors, trying to have a concentration on the workflow or trying to adjust the workflows and evaluate the entire team to improve the quality. So moving to the continuation section of what are the other things that are being discussed in process and project metrics are, as you can look on the screen, measures. So what exactly are measures? Measures are nothing but, in the other terms, the measurements that are collected for a particular product or a project, right? So it is generally collected by a project team. And once they are collected, you are trying to convert the collected things into metrics. As I told you, metrics are measurements for a project. Next, they can be transmitted into a proper responsibility. Like each one has their own, there are different teams in a software company or project holds different people. They have their own tasks, right? So the third point, which states, can also be transmitted to those with responsibility, meaning the metrics will be helpful to the people who are working in some specific area. I repeat, metrics are nothing but the measurements. In short, it is called as measures for the improving the software, right? And for this particular reason, as stated above, this involves both the process and the project domains. That is, for both these scenarios, that is process domain and project domain, you require all these measures. Fine. Moving to the metrics in process and project domains. So our concentration is on what are metrics, right? Metrics is generally for improving the software quality or a product quality or getting a good project done at the end of the day, right? So what exactly does this metrics mean and what do they do? As the first point says, it is trying to improve a process. We need to measure specific attributes of a process. That is, I repeat, whenever you want to focus on one kind of a process, you have to talk in terms of specific attributes. So for example, if I say features of a good process or a good product, what can I mention or state the features as? They can be tangible or intangible. Tangible are nothing but what we can see, feel, touch, and do. Intangible are some kind of services that are provided. And customer satisfaction or consumer satisfaction, business need satisfaction. All these are the features of process or project on a whole, right? Coming to the second point, that is trying to develop a meaningful metrics based on the attributes that have been stated. And finally, we use these metrics as indicators. Why are these used as indicators? So that knowing the values of these metrics or measures, you can improve the software quality, or in the process of improvement, these indicators will help us. Moving to one important note, that is, process is the only controllable factor in improving anything that you do in an organization. So I repeat, whatever you talk about the features, you talk about various attributes or anything. The first thing focus should be on, if you are having a proper control on the process, let it be defining various features within a process or trying to create an architecture, draw an architecture for any kind of a process. Process is acting as a major figure for controlling and improving the quality of any product. Fine. Moving to the determinants for software quality and organizational effectiveness. So this diagram depicts about how this process is revolving around these things, that is the product, the people, and the technology. As I have told you, there are 4 P's that were introduced in software project management, where the entire process revolves around those 4 P's, right? So looking at the particular diagram, these are the determinants for software quality and organizational effectiveness. That is, you will have to make the customer satisfied, or you have to involve the characteristics of the customers into the process, then focus on the business conditions, and also develop the environment where you are working in with proper measurements that are being defined. If the measurements are not up to the mark, try to improve those measurements, right? All these we'll be seeing in cost estimation. How do you talk about the mathematical things in these terminologies, that is metrics and measurements, right? So looking at the elaboration of whatever is there in the diagram, that is the process, product, people, and the technology, right? The first statement, that is process, right? It is acting as a center position or taking the center base for all the 3 things where the organizational performance relies on. Next, people generally focus on quality and performance, and product is really having a large impact on the team's performance. And finally, it is the technology which is having an impact on the society, right? Next, there are some etiquettes for software metrics, right? They are, first one is organizational sensitivity. That is, the data should be confidential. The data, whatever is defined, cannot be repeated. So there are some sensitive measures that are there within an organization. Next, regular feedback has to be taken. That is a very, very important metric. That is, etiquette for a software metric. Next, you have to, you should not use metrics for judging an individual, right? It's like you have to involve only them in the process or a project, or focusing on the goals, but not on the individuals. And clear objectives have to be specified. Clear goals have to be set. And next is Never use metrics to threaten individuals or teams. That is, if the values are not proper or something, you can adjust the values and get the results. But indirectly, there should not be any pressure on the team. That means to be said that. Next, this also indicates a problem area. One of the very important feature of the etiquette in software metrics is indicating the problem area. And if there is any negative things that are there, you try to improve it with the indicators, as we have just discussed. Don't fix on a single metric, meaning whatever values you are trying to specify to find out a cost estimation of a process. You should not rely on only single metric. It's like you can have multiple values so that any of the values stated in that range will give us a suitable result. Fine. Next, here we are talking about SSPI, which elaborates it as Statistical Software Process Improvement. What is this trying to do? As an organization becomes comfortable with collection and use of process metrics, that is, every process has their own way of executing their cost estimation, trying to know the lines of code, all these things, right? So for an organization, they have their own process metrics and they can be improved rigorously, or they can be involved in a rigorous approach called SSPI, that is Statistical Software Process, right? Trying to analyze the data that has been specified, knowing the values of it, trying to improve the values and get the analytics out of it. So that looking at the analytics, you can make some changes that have been obtained in the result, right? And this particular software is usually used to collect information about errors and defects, right? I repeat, SSPI, that is Statistical Software Process Improvement, is trying to analyze different kinds of errors and defects in a system and or in the product that is being developed. Next, so they are used for generally strategic purposes, right? I repeat, project metrics and the indicators derived are used by the project manager and the software team to adapt to project workflow and technical activities. So what is the main intention of project metrics? They are acting as an indicators to the software team so that they have a proper workflow and involve different technical activities, right? So the first application could be trying to focus on the estimation, that is involving more software projects that occurs during the estimation. So I repeat, the first application of project metrics on most software project occurs during its estimation. So whenever you are initializing an application, the focus or the strategy starts from estimating whatever has been defined. Next, whatever metrics have been collected from the past project act as a basis on the effort that is put and the time that has been considered, right? As we proceed through our project, the measures of effect and the calendar time, in short, it is called as the time that has been noted, is compared with the existing ones or to the original estimates. And finally, all this is focused by a project manager who tries to monitor and control the progress, right? And the main intention is in a twofold, that is in a two process, right? I repeat, project metrics is a twofold process. Initially, what happens? You are trying to first use these metrics to minimize the development schedule. First, we need to minimize the development schedule, adjust whatever things are needed, and focus on the risks that are occurring. Secondly, you have to assess the product metrics on the ongoing basis, like trying to every time note the things, trying to use whatever is necessary, trying to modify and improve the quality of the product. So I repeat, the intent of the project metrics is a twofold. So first, you have to concentrate on how you minimize the development schedule and how do you adjust the things, know the risks. And secondly, it focuses on the product quality. That is dependent on the ongoing basis. That is every time monitoring the data to improve the quality, right? So here we come to the mathematical notation of how do you write about this software project or products. How do you find out the cost of it in a mathematical notation? So we involve different types of software measurements. The first one is the size-oriented matrix. How do you define a size? How are you representing some values? How are you representing some values for a size of a program? Or all these things are discussed in size-oriented matrix. Second, we have function-oriented matrix. Then we focus on LOC, it is the line of code, and FP matrix, that is functional point matrix, object-oriented matrix, use case-oriented matrix, and web app project matrix, right? So looking at, I have listed so many metrics. So let us have a focus on what are direct and indirect metrics. So if you can look at the right side on the top, you have direct metrics, which includes cost and effort that is being applied. I repeat, direct measures include the cost and effort of the that is being applied. Next, it also includes lines of code, the execution speed, the size of the memory, the defects that are reported. That is all the things that have been specified for direct measures, right? Now coming back to the lower diagram that depicts the measurement in physical world are again termed as direct and indirect. So if you say direct, it can be a length of a bolt. If you say indirect measures, what is the quality of that bolt? That is the difference. Direct is nothing but what is the length? You know, how do you specify the length? Indirect, quality cannot be seen or known what it is. So it is indirect measures. So to know all these types of measures, we introduce the mathematical notion of how do you know the size of any kind of metric. So moving further, size-oriented metrics, that is the first one, right? So here what are we doing is, you are trying to calculate the size of a program. Now what is a program? If you consider any programming languages like C, C++, Java, and so many other things, we'll be writing us lines of code, starting off with the header files, and then starting the main function, then writing the lines of code within the block of it, and then writing the executable statements. That is the general scenario of writing a C program code, let us assume. So how do you calculate the size of that particular program? Is discussed in size-oriented matrix, right? Second point, size of the process allows us to do few things. What are those few things? That is estimation effort. How do you calculate the estimation effort? And then the time scale. In how much time are you executing the things that you have written in your code? Or total faults that are involved in the process. How many errors are being occurring in your process, right? These are the parameters involved to calculate the size of the process, or it is allowing us to define size in these three terminologies. That is estimation effort, time scale, and the errors that are being occurred, right? Next, this actually is a critical area in project planning. I repeat, size-oriented metrics is acting as a critical area or a very important area in project planning, because it is very difficult to know the size of the project, right? When we just get the end products, get the end applications, we actually don't know what is running behind, what is the code behind, how many pages of codes are there. So whenever you say size of a project, this is where we calculate the size-oriented matrix, which is acting as a critical area. Okay. Now there are various methods, or the methods used in this size estimation are lines of code. In short, it is called as LOC. And the next one is functional count, that is FC. Right. Now, what do you mean by lines of code? Lines of code are nothing but, in a program, we write so many statements. Right? You write header files, you write the main function, then you write the body of the program, right? Whatever question is asked, and then you write executable statements. In that, we also include comment lines, right? We also use comment lines, and then we also have some blank spaces. So to calculate the lines of code, you have to eliminate the blank spaces or in general spaces, and you have to remove the comment lines, right? What are these comment lines? Right. If I am writing one header line, hash include stdio.h, they are standard input and output. functions, right? So there may be a non-technical person for whom we elaborate and say that these are the header lines. That I write it using a hashtag. So that is called a comment line, where that has to be ignored when you are counting the line of code, right? So I repeat, line of code definition, it includes all lines containing program headers, declarations, executable and non-executable statements, right? The one thing that you have to note is, except comments, blank spaces, rest all come under LOC, line of code. For this, again, you have some pros and cons. That is, you have some advantages and you have some disadvantages as well. So let us see into the advantages first. The first advantage states that using LOC for size estimation, right? Using LOC for size estimation is an advantaged feature, right? Just by knowing the lines of code, we are able to estimate the size of the project or size of that particular program, you can say. Second advantage is, it is easy to count and calculate from the developed code. If you are having the final code with you, it is easy to count and calculate. So I repeat the advantages. Using LOC for size estimation is an advantage. Next, trying to count, it is easy to count and calculate from the developed code. Moving to the disadvantages or the cons of size-oriented matrix, the first one says that LOC is a language and technology dependent. That is, whenever you are trying to change technologies, so this calculation may vary sometimes. So that is acting as a disadvantage. Next, if we use software design, which is not up to the mark, it may cause excessive lines of code. So I repeat, the second disadvantage is nothing but, whenever you are trying to design a software with different process models and various architectures, they may be not up to the mark all the time. So which causes excessive lines of code. If you have excessive lines of code, unnecessary lines of code, estimating the size again varies. So that acts as a disadvantage over here, right? Moving to, how do you calculate the lines of code? I have just given a small program over here, which is trying to print greatest of two numbers. This is a C language code. So you have hash include stdio.h, which states that it is a header file. And then you have a main function, you have open braces, and then we start writing the code. If you have observed, there is a comment which says, ask user to input any three integer numbers. So this is ignored. Whenever you are trying to calculate the lines of code, you ignore the comment lines, right? So in C language, you use double backslashes, and in Python programming, we generally use a comment line with the help of a hashtag, right? So in this code, if you see, we have two comment lines. One is ask user to enter the input of three integers, and then store, the second comment line is store input values in variables for comparison. So totally our lines are 16. If you calculate from this program, I have partitioned the program on the screen in two columns, right? So they are totally 16, and removing the comment lines, my LOC becomes 14. That is, lines of code are 14. Next, the second thing, that is the functional count. In short, it is called as FC, or functional point analysis, FPA. So what does it state? This seems to be the solution, or in the other terms, you can say FC is trying to give us the solution about the size measurement of a problem, or it is having a count of how many functions are being used. So I repeat, functional count or FPA, that is functional point analysis, will give us a solution to the size measurement problem, having a count on the functions. So there are some special features for this FPA, which are nothing but, it is language independent. Next, estimating some development processes will be done in the early phases itself, and you can link up directly to the requirements that are already stated. And finally, it is based on user's external view of the system, right? The end product, how the user wants his diagram to look like, his architecture to look like. So this FPA focuses on that. Is user-friendly, you can say. Next, moving to the principle of FPA. This involves decomposition, of functional units. So what does this mean? So to solve some problems on how do you find out the cost estimation, how do you find out the size, we have to focus on the principle of FPA first, which is trying to decompose into functional units. The first one is the input. Input is nothing but what are the information that is being sent to the system or data entering to the system. Output, whatever information is being removed from the system or the data that is being removed from the system. You have the third category, that is enquiries, that involves both the input and the output as well. It is trying to request instance to access the data, right? Enquiry is nothing but it is specifying at that particular position that I have to enter the data, I have to retrieve the data, I have to send my data to it. All these things are enquiries that involves both input and output. And the fourth one is internal logical files. In short, it is called as ILF, right? It is nothing but information that is held within the system. And the last one is external logical files. In short, it is called as ELF. External logical files. And now what do these things do? They are trying to send information or hold the information to the other system outside, and it is then being analyzed. So I repeat, there are 5 major functional units for decomposing the FPA. That is input, output, enquiries, that goes both with input and output, internal logical files and external logical files. And let me tell you, in the further slides, I will be using the short form. So enquiries in short is EQ. ILF, that is internal logical files are ILF and external logical files are ELF. So moving to the next thing, that is the functional unit categories. Here they are broadly categorized into 2 things. The first one is transactional functional unit, that involves external input, external output, external enquiry. So in short, they are written as EI, EO and EQ. And the second category is data functional types, that is ILF, internal logical files, EIF, external interface files. So I repeat, the functional unit categories are broadly categorized into 2 main things. First one is transactional function type, that involves EI, external input, EO, external output, EQ, external enquiry. And then you have functional type that involves ILF and EIF. It stands for internal logic files, external interface files. So all these things has been depicted in a picture. Let us have a look at that particular diagram. So looking at the diagram, you have users at the left side, which is in the gray box, and then the top you have other applications. Other applications include hard disks, CDs and servers. Coming to the lower block, you have ILF, that is internal files, and EI stands for external input, EO stands for external output and EQ stands for external enquiries. Right? Now, looking at the connection, the EI, that is the input, is being fed to the application boundary and EO is coming out to the users from the application boundary. And there are bidirectional flows from the other application, that is from the servers, hard disks, linking up to the application boundaries. You have a bidirectional flow on EQ, that is the enquiries. And then you have external interface files, that is moving from the other applications to the application boundary. And you also have E0, that is moving from the internal to the other applications, that is external output. So in simple terms, let us have a relationship, or let us look at the relationship of the users to the application boundary. EI is the input, input is fed to the application boundary. EO is the output, it is given to the user, and there is a bidirectional flow which involves both input and output. That is why you have a bidirectional flow from the users to the application boundary. Coming to the other part, that is the other applications and the application boundary, is that input EI moves to the internal section, EO moves external output. There is a bidirectional flow for enquiries because it involves both input and output, and you have EIF moving towards the application boundary. That is, it is trying to show you the external interfaces, trying to give you a feel from the external applications to the application boundary. That is why it is an internal flow from other applications to the application boundary. Right. Moving to the calculation part of how do you calculate FPA, that is functional point analysis. To calculate the functional point analysis, firstly you need to calculate UFP, that is unadjusted function points. Secondly, you need to calculate AFP, that is adjusted functional points. I repeat, you are trying to calculate FPA or the functional count, as we have stated before. To calculate that, firstly you have to know what is AFP and UFP. AFP stands for adjusted function points and UFP stands for unadjusted function points, right? And looking at the formula, the product of UFP and CAF is giving us adjusted functional points. But how do you calculate CAF? CAF stands for complexity adjustment factor. So how do you calculate all these parameters that have been specified and the formula that is stated? So we just have to have a look at this particular table that is here. So here, this table is trying to talk about the functional units. What are the functional units? EI, external input, external output, external enquiry, that is the EQ, internal files, external interface files, right? ILF and EIF. And the weighting factor are assumed to be in the low, average and high terminologies. So low, you have some values already being defined. Average, some values being defined. High, some values being defined. Now, what are these values? If I say external inputs, low value 4, average value is 5 and high value is 6 for external inputs. Next, external outputs. 7 is the low value, 8 is the average value and 9 is the high value. Enquiries, that is, it is taking 4 as low, 5 as average, 7 as high. Then internal files, that is 8 as low, 10 as average, 15 as high. Then external interface files, 6 as low, 8 as average, 10 as high. So basing upon these table and the values that we have specified here, we will be seeing the calculation. Let us assume, right, basing upon different processes, the team will actually assess all these values. So let us assume or suppose that E1 equal to 10 of low complexity, right? 10 is the value given to E1 and it is some low complexity. And E0 is 12 of high complexity. EQ is 6 of average complexity. ILF is 3 of average complexity. And EIF is 8 of low complexity. Now, how do I calculate all these things? E1, as it is told, 10 into 4. Now, how are you taking this 4? From the above table that is being stated, you can see EI, the low value is 4. So, you just have to substitute 10 into the low complexity value, that is the 4. We get 40. Same goes with EO, that is external output, 12 of high complexity. Now, what is the high complexity? 9. So, 12 cross 9 is 108. So on with the other things. EQ, 6 of average complexity. So 6 of, what is the average complexity? 5, right? It makes 30. Then ILF is nothing but 3 of average complexity, that is 10. So 3 cross 10 is 30. And then you have EIF, that is 8 of low complexity. So 8 into, what is the low complexity? 6. The value is 6 from the table. So you write it as 9 cross 5, it is 45. Right. And to calculate the UFP, it is the sum of all these things, 40 plus 108, whatever values we have obtained in the previous slide, you sum up and we get it as 253. Right. The actual formula of calculating CAF is 0.65 plus 0.01 into summation of FI. Now, what is the summation? The total complexity adjustment value, right? This FI is called the degree of influence and one based on the responses to the standard questions. Now, let me tell you something about this FI. This FI is nothing but the factors that involve to answering some standard questions. Okay, let us assume we are focusing on one particular scale from 0 to 5. I am considering 0 as no influence, 1 as incidental, 2 as moderate, 3 as average, 4 as significant, and 5 as essential, right? This is just as an example. But whenever there is some execution going on within a project, here I have just specified 5 factors. Like that, you can specify 10 factors where your 6 can be efficient, 7 can be optimal, and so on. So just as an example, I'm trying to take a scale of 0 to 5, specifying each value with one particular factor. So now what is the use of this factor is that whenever you are trying to consider the factors, I state some questions. I say, do the systems require reliable backup recovery? If I say it is average of Fi, then if I say data communication is required, then I say it is moderate. Moderate is taking F2, that is on the scale it is taking 2. Then if I say the process is distributing, it is taking the factor as 3, whose value is again 2, so on. So the factors, it is the choice of how the process is being executed. And finally, you need to summate all this, or you have to sum up all these Fi values. It leads to 16. And finally, we substitute in CAF, which is 0.65 into 0.01 into the summation, right? And this finally gives us the total AFP, which is UFP star CAF. That is, will give us the final adjustment factor. That is AFP, which is 202.4. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.